Thank you, everyone, and appreciate everyone chiming in today. What my goal with today's conversation is really to kind of share some experiences that I've had as an open source leader, looking at how we work with our projects, how we've moved our project forward to try to adapt and overcome the things that come with being an open source project and the industry having such a shift into open source or over to cloud technologies. And one of the biggest things that we've been looking at is what does this really mean? How does this work? What is it? What is the impact to us as open source leaders, and how do we embrace the cloud, but also survive the cloud, which is something that I think from a open source project perspective is often overlooked. A little bit about myself. My name is Mitchel. My company is IowaComputerGurus. We do a lot of custom software development work in the Microsoft stack primarily. I am a Microsoft MVP, ASP Insider. I'm a member of the .NET Foundation. And most notably, I'm the technology group leader for the DNN platform open source project, which is a very large .NET CMS. I also have a number of other open source projects that are kind of sponsored by my company. So I spend a lot of time working in the open source space, some with large projects, some with other smaller projects. And so just kind of going right into it, I think it's one of the things that we have to look at from the very beginning is that managing any open source project is met with its own challenges, regardless of if we're going for the cloud or we're going for just a regular run-of-the-mill application. We have a lot of things that impact us as open source leaders that we need to take into consideration, right? Policies and procedures are probably the number one thing. What do we do? How do we accept things? What do we do to accept things? And how do we review things for our open source projects? And the reason why I start with this is probably one of the most important things that we have to have in place before we even start talking about embracing the cloud. Adding new technologies, adding support for new things, or saying that you are cloud ready is something that is really warranted with a good policy around how do you accept something new. And my reasoning behind this is the second that you say you have something, the second that you say you do something, you've started to open yourself up. So you want to make sure that you have a solid policy and procedure in place around how do you accept something new? How do you accept a new contribution? And one of the areas that the DNN platform project, for example, that I work with that we lack is we do not have a policy right now that requires documentation for new features. So what can happen is we can get a new feature, let's just say support for a particular cloud, and we wouldn't necessarily be bound by policy to say, oh yes, we have the documentation necessary to be able to accomplish that and support that long term. We obviously also struggle in most open source scenarios with managing quality. So this is going to vary depending on the particular project that you're working with. Do you have developers and testers as contributors to your project? Are you primarily developer focused? Do you get end users in? This is something that's a challenge for us day to day in most open source projects. As we start to talk about embracing the cloud, we have to make sure that we understand what quality impacts we might have and what community resources we have available to us as part of that process. Lastly, one of the biggest challenges that we have is coordinating our contributors. So everyone in the open source world, right, is contributing on their own time, on their own dollar, on their own passion for contributing. So how we manage that, whether we're making sure that we're giving thanks, identifying the actions, and highlighting the contributions of others, this is something that plays really well into the fact that we also have a roadmap concept. So when we have everybody that's contributing on their own dime, of their own prerogative, when they feel like it, it's very hard for us to set a roadmap. It's hard for us to triage our features. What are we going to do? How are we going to do it? Are we going to commit to it? And this is something that I think is a really big struggle for most open source projects, is what's going to be in the next release. Unfortunately, if we look at it from the most basic foundational level, the only thing that we can commit to is the stuff that we received a contribution for. This puts us into a little bit of a tricky situation as we look at the longer standing, what are we going to do from an open source perspective? I'll come back to this concept in a little bit, but I just want to make sure we kind of all understand some of the things that we deal with on an open source basis, regardless of if we're talking about cloud technologies or otherwise, right? We're managing an unknown roadmap with an unknown amount of developer resources, and we might not have all of the tools necessary to do the things that we would do at our normal job, right? A lot of us have the backings of formal QA or otherwise. And why are we talking about the cloud? Well, the cloud momentum is growing, right? We see people go into the cloud for a number of different reasons. Some are touting cost savings, getting rid of on-site hardware. They don't want to be in the data center business. They want to manage overall their footprint. They want to be able to support scale. They want to be able to support new deployment strategies. For example, we want to be able to be geo-redundant. What happens if our data center in Iowa gets taken out by a tornado? We want to be able to be back up and running on the East Coast in the short time possible. For these reasons and many more, we're seeing the cloud growing. As we look at metrics that are available, these I happen to grab from hostingtribunal.com. A number of other places have similar metrics. Everybody seems to slice this a little bit differently. But there's some key things that we want to look at from an open source perspective. The cloud service market expected to reach over $600 billion by 2023. I think this number is very conservative. When we look at enterprises, more than 94% of them are saying that they already use a cloud service in some capacity, with 30% of all IT budgets being allocated to cloud computing, and 66% of enterprise teams already have a central cloud team or a cloud center of excellence. And organizations leverage almost 5 different cloud platforms on average. Just stopping right here for a moment, we start to see the picture of what we might need to be looking at in our open source projects. If we have no cloud strategies, if we have no cloud understanding of how our open source project might fit with the cloud, you can see here how it's important for us to embrace this, because we are already diverging from where that industry is moving, right? If 90+% of enterprises at least use some sort of cloud services, you can only assume that those usages are going to continue, right? IT budgets, 30% of them going to cloud computing. It's definitely pointing us in a direction. The interesting metric here is that organizations leverage almost 5 different cloud platforms on average. This brings into the concept of disaster recovery and redundancy, and something that we really want to take into consideration with what we're building. We can leverage the Azure cloud and do everything we want. We can leverage the Amazon cloud and do everything we want. But what happens when Azure goes down? Well, Amazon should probably be up, right? And we're seeing more organizations, especially the large enterprises, wanting that flexibility or portability to go from one cloud to another. Might be something that we want to look at in our projects. We can see here that 50% of the enterprises are already spending a boatload of money on cloud. Public cloud infrastructure this year is expected to grow by 35%. I think that number is also a little bit light, and lots and lots of data. So why do we care? Why do we want to adopt or embrace cloud for our open source? Number one, we want to make sure that we maintain our relevancy. If we show support for a particular cloud, it can make it easier for your project to be considered. It all depends on the type of project that you're going for, but think of how people discover your open source project. Most of the time, right, they're going to be discovering it through word of mouth, Google searches, Bing searches if you're so inclined, or otherwise. So being able to show support for a particular cloud is going to allow your project to get visibility within the keywords or functions that you are targeting. If you don't have that out there, it's not something that's going to be as easy for you to discover, or it's going to be a common, frequently asked question. You're going to see a lot of things in maybe your GitHub repository where people are like, hey, do you support running on Azure? Do you support running on Amazon? These are kinds of things that you have to take into consideration. We also might be able to benefit from an ease of deployment. This is something that is often overlooked by a lot of open source projects, and I see more of them are starting to get on the bandwagon here and start to embrace the cloud deployment model. If you make your solution available easily within the clouds, whether you go to the Azure Marketplace and you can do a one-click install of your product or similar things, this is something that might make your project a lot easier for people to discover. If I can just simply go out and browse the marketplace in Azure, and all of a sudden I stumble across platform X, it's going to be a lot easier for me to, even out of curiosity, get started with it. If we look in the industry, the reason why you see things like Wix and Squarespace or the various storefronts growing, it's because it's really easy for you to go out, click, hey, I want a new online store with Shopify. 3 clicks later, you have it up and running. They didn't have to learn anything. And then we see a lot of open source projects starting to take that into consideration as well. Now, the problem is we also need to look at the negative side of the cloud. Compatibility issues might be the other reason why individuals that are using your product might no longer be able to use your product. Because if we have compatibility issues, if we don't work well in a cloud environment, we're going to start to lose people from our platform. And this is something that we've seen a lot in the .NET Nuke community, where a lack of cloud support has resulted in people either A, having to go through a lot of extra development effort, or B, it's resulted in them looking at other alternative solutions or doing other things, myself included. Geo-redundancy, for example, is something very, very hard to implement with most content management systems, .NET Nuke included. It's something that requires us to often look outside of the box of our open source project that might otherwise be able to support everything that we're looking for. So what are some of these compatibility issues, right? For those of us that maybe don't play in the cloud a ton, what kinds of things do we see commonly reported by individuals that don't work in the cloud environment? Caching is probably the absolute biggest thing that that people miss in cloud implementations. Cloud environments are often supported with multi-server. With Azure, for example, it's really easy. You click a button, it's going to auto scale. You get to high CPU, voila, you have an additional web server. Oh, you need another. It's very easy for that to be able to be completed. However, many developers are still using older methodologies or older technologies, and they're leveraging caching mechanisms that don't necessarily work in a multi-server environment. Or they do have something that works in a multi-server environment, but it has server-specific dependencies. So this is one of the big areas that we've seen in our open source usages, is that server-specific dependencies are often overlooked. Hey, I have a job scheduler that needs to run something every hour. Oh shoot, in a multi-server environment, I need to make sure that runs only once. Oh, I'll just make it work by server name. Well, that works until you get into some of these scheduled jobs, because these scheduled jobs, if they rely on something that you think is stable, right? Historically, we've thought the network card, that's a device ID, it's stable. We've seen server names. Oh, that should be stable, right? In the world of cloud computing, these things are no longer stable. We can, in an Azure environment, potentially shift server names as often as 2 or 3 times an hour, if not more. Some installations won't see that level of shift. And it's important for us to understand what we're doing and what the clouds are doing. Unfortunately, what this means is it means that we have to understand what these clouds do. And that's something that a lot of projects are not necessarily as willing to go through and do. And unfortunately, this is something that we will continually fight over time. And this comes back to getting more contributors, getting people interested in your product that maybe have different experiences. So understanding where you might benefit, putting some guidance together, putting some documentation together is going to be one of those areas that we can really help. Now, obviously, compatibility issues, this is a pitfall. This is something we have to work around. But with this difficulty, we also get opportunity. By leveraging the cloud, by embracing the cloud, we can do things that maybe we couldn't do before. So for example, the .NET Nuke project has an internal job scheduler. Let's be honest with each other. It sucks. It uses web requests or a background thread on the web server to make sure that scheduled tasks are done. We say run every 15 minutes. The reality is it runs every 15-ish minutes. If we were to embrace the cloud, we could take those specific tasks and move those to web jobs, something that is an Azure specific implementation for job runners that would have a much more guaranteed execution time. The benefit for our users would be amazing, but it's only going to benefit those users if they're on an Azure platform. And this is where we start to get into this interesting scenario. What and where and how do we support things? We'll come back to that in a little bit. Other things that we can do is leveraging things like cloud storage. So even if we don't change the way that our application works, maybe we change the way that our application stores the data. We can store our data to an Azure blob or an Amazon S3 container. Getting that content away from our website, serving that content by others, provides a real interesting scenario, because by moving those things off, moving the web requests away, we all of a sudden get basically a free performance boost. I'm sure a number of you today that are here today have experienced some of those benefits of, hey, I'm going to put a CDN in front of my website, right? Boom, we get a bunch of performance hit or performance gain. That's the same kind of thing that can happen as we start leveraging cloud storage providers or otherwise. We can also then do things like get global redundancy or resilience. We can do things such as, hey, I want my database to be in the North Central region, but I want to have a hot spare in the East US, right? We can do these kinds of things. We can support these kinds of things. We can document these kinds of implementations for our open source project users, so that when they come and want to do something that's higher scale, higher quality, we can be out there in the forefront saying, yes, we can do that. Yes, you can utilize this product in that configuration. And that will do only good things to help further your adoption of your project as a whole. So now the real question becomes, though, what do we support? Who do we support and why? So as we look at our clouds that we have out there today, we obviously have the Azure cloud, we have the Amazon cloud, we have the Google cloud. Do you support them all? Do you support only some of them? This is where understanding your audience becomes a critical piece. The other thing that we have to look at is cloud support on by default, or as I like to say, required? One of the big things that's been tossed around in some of the open source channels that I'm in is we are Azure focused. We are going to only work in an Azure environment. Just as much as being Azure supported is a way to grow your audience, saying that you only work with Azure is something that is also going to limit that audience. And this is one of the big things as an open source leader that is unfortunately a really complicated decision. And it's much more of a product manager type decision that not a lot of us developers or other IT folks that are doing things, we're not necessarily as capable, willing, or as experienced to make some of these decisions. If we decide to embrace the Microsoft cloud and we decide that that's all we're supporting, we've closed ourselves off to a potentially very large audience of others. The other thing that we have done is we have locked our users into a technology stack. And as much as I would love to say that I love Microsoft and I love Azure, because I do, I also love the ability and the portability to run on something else. So this is where, as we start to look at implementing features, sometimes it's not just good enough to say, we work with Azure, we work with Amazon. We need to be able to say, I work with the cloud. Choose your cloud. This is something that is very hard to understand or to try to diagnose, but then we have to start looking at what happens after. So what is life like after we say, we are going to support the cloud? We're going to embrace whatever technology it is that we're using. So first of all, we get the common things. We get external dependencies that get introduced. And anytime you add an external dependency to your open source project, you now have additional things that you have to manage, right? What happens if you get an upstream process that has a break and change? Azure storage is a great example of a break and change that has cascading impacts. Older versions of the APIs for Azure storage required you to provide a storage account name and a secret key. The new method that works with the Azure storage APIs is you need to provide a connection string. Well, this is a big change for many applications because not only did the methods change in the code, the data that you need from your users is now changing. So now you have a break and change. What is your project's break and change policy? Is that something that you can release with a patch release, a minor release, a major release? How do you then go through and manage taking that break and change within your dependency and moving that upwards into the project, getting that communication out to your users and identifying what risks might come with it? We also have the concept of just tracking and managing those updates. How do you know that Microsoft made a change to the storage API? How do you then test what you've done and making sure that everything is still working? Cloud environments require you to test in those environments. You can get certain things for free, right? Microsoft has certain free tiers of various things like storage. Amazon has a free tier, but you have to make sure you have those resources available to you to test and validate. You want to ensure that those integrations continue to work with each and every release of your open source project. What comes with all of this is you start to fragment the support model for the rest of your project, right? Remember, we're working with a finite set of resources. And on top of it being a finite set of resources, we're only getting these resources when they are ready, willing, and able to contribute and work with our project to give us their time and sweat equity to help us move forward. So adding support for cloud storage and deciding to support Azure and Amazon and Google is going to result in us maintaining 4 storage providers, because we still probably should support local storage, right? Not just a cloud only focus. Now we have 4 things to support rather than 1. We have 4 different pathways in our code that we have to test with each release. We have all of these things that we now have to support, and we did this potentially to just check a box. Well, it's not that big of a deal. Azure storage doesn't necessarily change that often, which is a valid point. However, it is really important to understand that once you adopt the cloud, not updating can be far worse than not even having support. And some prime examples of this are when the clouds make a large or quick shift in process. So if a cloud provider rolls something out and all of a sudden the feature that you were leveraging before is gone, now you don't just have a, oh my gosh, this doesn't work on Azure. You have a bunch of people that are on Azure and their sites are stopping working, or their applications are no longer processing data in the way that they expect. That can have an even more negative outreach, a more negative press within your communities than simply just saying, hey, we don't support Azure. We'd love to, but we need contributions to get there. I'll give you a great example of exactly this problem, and it ties in the policies and procedures with breaking changes and bringing in downstream solutions. So the DNN platform has an Azure Cloud Storage connector that allows people within the content management system to take files from their local machine and upload them to the application, right? So you want to put an image on your homepage, you want to upload a document for people to download. A solution was implemented that allowed the websites to store the stuff to Azure Cloud. It works. The real advantage here is the websites can reduce their footprint substantially by offloading those requests to Azure. And the performance gains of doing so are exponential, especially on content-heavy sites. We've seen situations where individuals have seen performance gains in excess of 80 or 90% in additional throughput by just simply storing something on the cloud. The other thing that has happened that was slightly unintended is backups and restores become substantially faster, because now instead of uploading 3 gigabytes worth of website content to the local site, every time you go to do a backup or an upgrade, I don't have to zip that content up. It's safely stored in a cloud storage provider. That cloud storage provider supports snapshots. That cloud storage implementation has all kinds of things to be able to roll back, including recycle bins and otherwise. So we can do our backups and restores quite quickly. This saves money, this saves time, makes upgrades easier, makes even moving and relocating the sites substantially easier. Now the downside, Azure changed APIs. Those APIs resulted in a break-in change. That break-in change means your configuration is literally something different than what it is today, i.e., we are collecting a brand new piece of data that we've not been collecting before. Now, the platform has a policy. The platform's policy is that we will not make any breaking change unless it is a major release. That's a problem, because now what we have is we have a API dependency for Azure Cloud Storage that has to stay pegged back at an older version before the changes to the API for a period of at least 18 months or so, given our current development velocity, because we cannot do anything until we get to that version 10 release, which is our next major version. This is a risk. This is a big risk for our end users, because our own breaking change policy might make it so that something goes wrong. Because Microsoft, once they say, hey, this is going away, when do they finally pull support for it entirely? No one really knows. There's no official answer, but it's something that we have to consider. So this is something where the combination of the cloud plus our own internal policies plus those people that are contributing to us have really resulted in something that's a little bit complicated. And with this, right, we want to make sure that we look at what the real ramifications of this are. On top of all of this, in this scenario, our contributor that built this did not follow all of the standards. It's something that we didn't fully approve. And now we have to go back and figure out how to support it. So as we look at some of the lessons learned, some of the things that I've seen over the years, what are some recommendations on how you can manage the cloud transition? What can you do to make your life easier as an open source leader? So first of all, tracking your dependencies is absolutely critical. Dependabot and the other types of tools that keep track of change notifications and everything, they are amazing, but they're not enough. Make sure that you find out where this information gets published. Where do they put release notes? Where is the most recent build? Have that information in a centralized place, whether it is in the documentation of your project, whether it's something that's only private for the individuals that are managing the project. Make sure you know where is the dependency, what is the dependency, and how does it get updated. The other thing that is absolutely critical, do not modify existing sources if you're pulling a dependency. We have had a propensity in our open source project to bring in a dependency. Oh, we need to tweak this little thing. Oh, well, we'll just change their code. So now we have a fork, and now it's impossible for us to kind of bring things back together. Well, what happens when that upstream library has a security vulnerability? Well, now we have to take and go back and look at all of their commit history, figure out what they did and how they solved that. And then we had to patch it into ours. Find a way to bring the dependency in and keep that dependency as is. Add your custom stuff afterwards. Make the modifications to support your platform after you've brought that into the project. Make sure that you're able to use it as it is. It will simplify your life for the better in ways that you can't really even understand until you've been there. And then on top of that, only bring in the things that you can support. If somebody makes a contribution of a support for Google Cloud and you don't have any maintainers that know anything about Google Cloud, take a step back and seriously consider whether you want to bring that into your project. There's nothing wrong with there being additional pieces, additional things that are offered by third parties or other open source contributors. It doesn't need to be in your project unless it's something that your project can really truly support, because it's your reputation, it's your project's reach that's governed by how you release things. If somebody releases a third-party thing that connects to the Google Cloud and it doesn't work well, that is far easier for you to be able to document and show that you don't have support for that yet than it is to be the ones that release something that doesn't work for anybody. And it's all about managing those long-term expectations.